Hello, students of class 7. How are you all? I'm your science teacher, DPS sir, from LPM Public School, Gola Bazaar, Gorakhpur student. Student, as you know, our chapter, student, our chapter number 13, that is electric current and its effect, which is already under process. And in this topic, today I will explain you about the different effects of electric current. So student, here I will explain you about the different effects of electric current. So there are three different effects of electric current, as you can see here. When an electric current passes through a matter, it gives three types of effects, and those effects are heating effect, magnetic effect, and chemical effect. So these three effects you can see when a material can react, when the electric current could pass, it could give its heating effect, magnetic effect, and chemical effect. So student, in this chapter we will study how the heating and magnetic effect of the current takes place. So let's start the topic about the heating effect of electric current. All the materials, all the materials oppose the flow of current through them. The degree to which a material opposes the flow of current through itself is called its resistance. Resistance means the things that resist or stop tries to stop, which acts in opposite direction to stop the moving of the electric current, that is called the resistance. So resistance also allows the current to flow in that circuit in if in a very slow process, so it will be time taking. And when, as long as the electric current will be stopped within that apparatus or within that wire or within that equipments, that will create more heat. That means if by stopping the electric current, or you can say not stopping, holding, so that as much as the electric current will be hold there, that much heat will be created in that appliances, and which will cause a heating effect. So student, all the material oppose the flow of current through them. The degree to which a material opposes the flow of current through itself is called a resistance, and that material which is applied in the circuit to hold the electric current is called resistance. When a electric current is passed through a high resistance wire like nichrome, the wire becomes hot and produce heat. So what I just now told you, student, such a material that can hold the electric current for a long time, and that converts into heat. So such wire is the nichrome. The wire becomes hot and produce heat. This is called the heating effects of electric current. Student, in this activity you can see here the study of effects of electric current on the bulb. Make an electric circuit by connecting an electric cell. You can see here in this figure how you can see here in this figure how a electric bulb is connected with a bulb bulb with a cell, with a wire and a switch. So student, as you have seen here, this is the whole arrangement of the apparatus, how the electric current to make a circuit. This is a closed circuit where the bulb, the cell, the two terminals, wire and the switch are both all are in closed circuit. So you can see here that this one is an example of closed circuit. You can see here, student, that this one is the example of closed circuit, as because you can see here the switch is closed, the bulb is glowing, and there is a cell, and nowhere the wire has been broken. So this is the complete circuit. As well, you can see in the upper figure here, there you can see the wire is there, the bulb is there, but the bulb is not glowing, the cell is also there. Okay, student, but you can see here the switch is open, that means it is a open or broken circuit, and in this case the bulb will not glow. So you see, as student, that keep the switch it off, does the bulb glow when the switch was off? In this case, when the switch was off here, was the bulb glowing, student? No, the bulb was not glowing. But in this case, the switch was on and the bulb was glowing. So now, do you know how the bulb light up when it is switched on? So student, a question has been asked that do you know how the bulb lights up when its switch is on, or you can say when switched on? Study a bulb closely here. You can see here the bulb very closely. You can study here. This is a terminal. This is an aluminum cap here. This is terminal. This is aluminum cap here. This is the glass stem on which the this you can say nickel iron lead supporting wire is there, and on that tied a material made up of tungsten which gets heated. When it is connected with the cell, the electric supply that will come, it will heat this terminal, and when this terminal will get heated, as long as it will hold the current, it will make the tungsten, it will make this tungsten more heated, and it start giving light. So student, in its center, you will find a coil, a thin wire called the filament. So as I have just told you, you can see here that this is the filament here. Okay, student. Now, when the filament breaks the circuit, so you can see here the when an electric current passes through it, the thin wire inside the light bulb glow white hot, and when the filament breaks, and if suppose that if this filament, if suppose that if from anywhere this filament will break, then the bulb will not glow, student. So, so when the filament breaks, the circuit breaks and the bulb doesn't glow. The filament become hot because the thin wire offers resistance. As this thin wire offers resistance, it hold the electric current for a long time in this wire. मीन्स जितना वो करंट उसमें उलझा के रखेगा, उतना अधिक देर तक वहाँ पे करंट रुक पाएगा, जितना अधिक करंट को वहाँ रोक पाएगा उतना अधिक वो हीटेड होगा, और जब जितना अधिक हीटेड होगा उतना ज़्यादा वो प्रकाश देगा. So the filament becomes hot because a thin wire offers resistance to the current. As the electrons are forced through this thin wire, they heat it, and when this wire passes this thin wire of tungsten, okay, it heats up, and when a bulb is filled with the inert gas, and the bulb is filled with the inert gas like the argon or the nitrogen are used because they do not support combustion. So the bulb filled in this gas, in this bulb is argon and nitrogen. It is why so? So that there might not catch any fire or flame in that inside that bulb. That's why these two gas prevent it from catching flame, okay, because of heat. So argon and nitrogen are two gases. Now student, a small activity here you can see to study the heating effect of electric current. Here you can see that a board is set on which a two terminal like nail is there pricked on that board, and it is tied with a nichrome wire, and is its one side is connected with the cell, and its other side touch the wire after a few minutes. By switching off the current, the wire gets hot when the electric current pass. After switching it on, when you will try to touch the wire, you will feel the wire has gone hot. The amount of heat produced in the wire, so the amount of heat produced in this wire, okay student, is how? Number one, resistance of wire. Just now I have told you, in this case, resistance, as much as it can stop the hold the electric current, that much that wire will become hot. So student, the amount of heat produced in the wire depends on, so how much that wire will get heated, that depends on the resistance of the wire. That just now I've told you, how much is the resistance, that much the current will flow slowly, move slowly, and the wire will hold that electric current in its for a longer time, and as much as longer time it can hold the electric current, that much hot the wire will be. That means greater the resistance of the wire, greater will be the heat produced. Copper has a very low resistance, but copper has a very low resistance. It can't get heated. When nichrome has a very high resistance, whereas nichrome has got the very high resistance, a short wire and a thick wire has a low resistance as compared to the long wire. One more comparison, that if a wire is short or a wire is thick, that means its holding capacity of electric current is poor than compared to the long wire and that of a thin wire. So a short wire and thick wire has a less resistance as compared to the long wire than thin wire. And next is the magnitude of current. Magnitude of the current. Greater the amount of current, that means greater the power of current passed through a wire, greater it will produce the heat. That means the heat depends on two things. One is the resistance. If the resistance is more, then the power is, means the heat is more. And if the next is that magnitude of the current is more, that means the power of the current is more, the current will also be more. Okay student, a number of electric appliances make use of heating effects of electric current. A number of electric appliances make use of heating effect. Many of the electric appliances make use of heating effect of the electric current. A heating element is a part of heating appliances which is of high resistance and is heated when an electric current flow through it. So, student, the heat of the wire, or that you can say appliances, depends on the behalf of two things. One is that the power of the electric current, and the next is that the resistance. Good conductor like copper, silver, aluminium offers less resistance and do not get heated easily. Now, student, so again repeating, the good conductors like copper, silver, aluminium, these are all of less resistance. It doesn't hold the electric current too much, and so that's why they do not get heated easily. Whereas the alloy like nichrome, that are commonly used to make the heating effect element, that are mostly used mostly used in making the heating effect of the electric current, just like for you can say heater or iron, of which you can just iron do the ironing of that cloth. So it is made up of nichrome is there. Whereas so nichrome has got a good resistance capacity. That's why the articles, or the you can say equipments, that is used uh, only by the means of heating effects, that in that nichrome wire is used. Some of these appliances are electrical heater, toaster, iron, hair dryer are all made up of tungsten. There a tungsten wire is present. These appliances have coil of resistance wire. So they have the coil, means rounded wire present in it, that could hold the electric current for a long time. The figure shown in the electric hair dryer and the coil of the wire glow, sorry, glow in heat when the hair dryer is switched on. Air is heated up by the coil and the fan blows the hot air out of the hair dryer. So inside it gets heated, and as much the coil inside is too much here, the coil is here is too much wounded here. Too much coil is wounded here, and this too much coil, okay, acts as a resistance and hold the water. Sorry, hold the wire in which the current is flowing through it. Now, student, good conductor like copper, silver, aluminum offers less resistance. If a conductor is made of this type of good conductor, then there is a less resistance, less holding capacity. Whereas alloy, such as nichrome, that are commonly used, is the mid heating element of a often very high resistance. So here you can see here alloy, which is made up of nichrome, is have got the higher capacity. Some of these appliances are electrical heaters, toasters, iron, hair dryer, and so on. These appliances have coils of resistance wire inside them, which convert electric energy into heat energy. Now the figure shows as the electric hair dryer and the coils of the wire glows with heat. When the hair dryer is switched off, the figure shows in the electric hair dryer and the coil of wire glows with heat, and when the hair dryer is switched on, the air from inside is thrown the fan which is present inside the that material that blows the air, and as because the wire is coiled there, that can hold too much heat, and behind from that the fan which is blowing throws out the heat from inside and makes let the hair to dry. Now, student, my topic about the fuse. What is a fuse? Student, there is such a safety device that is present in electric utensils as well as it is applied in the boards so that to keep the electric appliances safe from heavy power of electric supply. Sometimes happens that heavy electric power reaches our homes and destroys the expensive electrical appliances. So to avoid such type of loss, a fuse is used in the board so that if a heavy electric supply would also come, then the fuse will burn and the circuit will break. So a fuse is a safety device in an electric circuit which prevent the electric fires and damage of electric appliances. A fuse wire consists of a short length of thin. So this thin fuse wire which is present inside the fuse, so you can see here a thin wire is present here which acts as a fuse. You can see here this acts as a fuse inside that fuse present, so that if the much electric flow, the fuse wire melt before anything damage. So if the power is given to this wire, if more from this power has came electric power has came, it's automatically burn the inner connection and stops in any havoc, creating any havoc conditions. Now, student, take a thin strand of steel wool between the two nails and shown figure here. Connect the nails to the two terminals of the 4-cell battery through a switch. Your fuse is ready now. Look carefully at the strand of steel wool while you press the switch. What happens? Now, student, so as I just explained you just now that about the fuse, and the fuse is such an electric device that is used to control the heavy power from reaching the home appliances and keeping the home appliances safe. So for today's student, up to here only, and you can see here, this is a device, and here are the wires which are present. Okay, so this is all today, student. Meet you in the next lecture video. Till then, thank you. Have a nice day, student.